All right, so in the geometric sequences, all right, after we did that video, on the first drop, her rope stretches approximately 200 feet. And then as she goes back up and she comes back down, it stretches another 80 feet. And then on the third drop, it stretches 32 feet to ultimately have a stretch of nothing. Okay? So this allows for you to create a rule to predict what the stretch or what the value would be depending on how many times it bounces. All right? And so this is the rule that we're going to use for geometric sequences. Okay? And we did this before with arithmetic sequences that looked like this. A sub n equals the difference times n plus a sub 0. Remember that? Briefly, we're going to do it again. But this one right here says a sub n, any term in the sequence itself, is equal to the first term times the common ratio raised to the n minus 1 power. Okay? So this is the table that talks about the bounce off of the jump. First bounce 200 feet, second bounce 80 feet, third bounce 32 feet. All right? So what am I doing each time? Well, you have to ask yourself, what am I multiplying by each time? Now, that's kind of a hard thing to think about because if I'm multiplying by something, how is my number getting bigger? All right? But if we say, let's just do 20. 10. 1. What are we doing each time? Huh? I'm sorry, I didn't mean to do that there. 5. What am I doing each time? Okay, so we're dividing by 2, but what are we multiplying by? 1/2. Okay? So if my number is between 0 and 1, then my values are getting smaller. So let's go back up here for a second. What are we multiplying by? Huh? No? So I want you to well, let's see. We know that we're dividing by something. So let's take 200 divided by 80. What do we get? Huh? 2.5. Okay? Now 2.5 as a fraction is what? Huh? Okay, so we'll say 5 over 2. Okay? All right, so 2.5 is 5 over 2. Now, I'm not multiplying 5 over 2 each time. I'm multiplying 5 over 2 this way. What am I multiplying here? 2 over 5. Okay? So in this case, my common ratio is 2 over 5. Okay? All right, so let's look over here. You're given a penny. Okay? 1 cent on the first of 20 days. Each day, you're going to receive twice the amount as the previous day. How many pennies will you have, can't spell, on the 20th day? Well, let's look. On the first day, we have 1 penny. On the second day, how many pennies do we have? 2. On the third day, how many pennies do we have? 4. And then so we can see here, how many pennies do we have? Okay. So what are we doing each time? What are we multiplying by each time? 2. Okay. So in this case, my common ratio is 2. Now remember, in sequences, the first term, a sub 1, a sub 2, a sub 3, a sub 4. So my first term is 1. We want to know how many pennies do I have on the 20th day. So if we go to the rule here that says a sub n equals a sub 1 times r raised to the n minus 1, then we're going to fill this in. We want to know on the 20th term, the 20th day, that if I started off with 1 penny and it doubles each day, how many do we have? Okay? So we have 1 times 2 to the 19th power. Now remember, in this case you could, but in most cases you can't. You have to do the exponent first and then multiply by this number. So somebody tell me how many pennies we have on the 20th day if we doubled them every day and we started off with 1 penny. How many pennies do I have? I got something different. What does somebody else have? 361 or something like that? What'd you get? You know how many pennies we have? We have 524,288 pennies. Okay? If for 20 days I double the amount from what you had the day before. Pretty impressive, huh? All right. So, are we good with the next 3 terms on this one? What do we do each time? Multiply by 4 each time. Okay? What are we multiplying here each time? What? But notice, my sign changes. So I'm multiplying by negative 1/3. Okay? Because negative 9 times negative 1/3, positive 3. 3 times negative 1/3, negative 1. Okay? So if my sign alternates, it's a negative value that is our common ratio. Okay? All right, so I want you to do this one. Find the 6th term in the sequence. Back to this for a second. All right, so the rule was a sub n equals the first term times the ratio is to the n minus 1. We are looking for the 6th term. The first term is 5. The ratio is 2. And we have to the 6 minus 1 power. What do we get? 160? Is that what y'all got? Okay. I don't trust Owen. So let's see. Let's do let's do this one and this one. What we got? What's the common ratio? What am I dividing or what am I multiplying each time? Nothing. It's not geometric. All right, number 2. What's the rule? Let's do the rule first. A sub n equals what? Negative 0.5. What's the ratio? 2 to the n minus 1. So the 11th term is what? All right. What'd you get for this one? No. Look. All right. First term, negative 1. Ratio, 1/3. And we're doing this to the 10th power, right? Okay. If I take 1/3 and I raise it to the 10th power, that's 1 to the 10th power over 3 to the 10th power, which would be 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And because I'm multiplying it by a negative 1, negative. Okay? $11 minus 1. Okay? All right. 3 to the 10th power. Wait, did I do that wrong? Oh, you know what? Yeah, you're right. I'm sorry. Dang. Ah, dude. 1 over. What was the number again? Yeah, no kidding. Why don't you come up here and teach it? All right, good. Do this one. So, the first second, 16 feet. Okay? The second is 80 feet.
The second one's 48.
48, sorry. 48. And 3 is... Never mind.